Let's start with the significant figures. We saw in the last time how we can round off numbers. It is important to write similar data in similar way, meaning use the same significant figures. For example, if we have 84.01 grams sodium bicarbonate reacts with 36.46 grams hydrogen chloride. When we record the data for the produced sodium chloride, we should round off the result to four significant figures, 58.44 grams. Let's look at these guidelines that can help you to determine the significant figures of your digit number. First guideline states that any number that is not zero is considered a significant figure. For example, 845.0 has three significant figures, 8, 4, and 5. And 1.234 has four significant figures, 1, 2, 3, and 4. The second guideline is about zero. Any zero between non-zero is considered a significant figure. For example, 40,501 kilograms has five significant figures, 4, 0, 5, 0, and 1. Zeros to the left of the digit are not significant and they only indicate the placement of the decimal point. For example, 0.08 has one significant figure, 8, and 0.0035 has two significant figures, 3 and 5. All zeros to the right of the decimal point count as significant figures for numbers greater than 1. For example, 3.040 has four significant figures, 3, 0, 4, and 0. And the number 40.062 has five significant figures, 4, 0, 0, 6, and 2. Another guideline. All zeros to the left of the decimal point don't count as significant for numbers smaller than 0. But zeros between non-zeros digits are significant figures. For example, 0.3005 has four significant figures, 3, 0, 0, and 5. And the number 0.090 has two significant figures, 9 and 0. All zeros after the last non-zero figure are called trailing zeros, may or may not be considered to be significant. For example, 400 can be considered to have one significant figure, 4, or two significant figures, 4 and 0, or three significant figures, 4, 0, and 0. Let's solve this exercise. How many moles of calcium oxide are there in 2.9 grams of calcium oxide? Knowing that the relative atomic masses value for calcium 40.1 and for oxygen 16.0. The molar mass of calcium oxide, CaO, is equal to 40.1 plus 16.0 equal to 56.1. The number of moles of calcium oxide, CaO, is equal to 2.9 grams divided by the molar mass of calcium oxide, 56.1, equal to long number that starts with 0.05169. Your answer should have two significant figures similar to the number 2.9 grams, which has two significant figures. So the answer is 0.052. The two significant figures are 5 and 2. Remember, when we round up 6, we add 1 to the one we have.